Nothing endures but change. One of the most used quotations certainly rings true in the market for energy storage. Changes in communications behavior, new production technologies, increasing awareness of regenerative energies, and the increasing demand for mobility all require technological advances. In the energy storage sector, large capacity capacitors are increasingly becoming a true alternative to accumulators or as a complement with batteries. Even with a simple torch, such developments don't stop. Waste-intensive primary energy sources such as batteries and accumulators can be replaced by long-life double-layer capacitors. LED torches can now easily be operated without a conventional energy source, thanks to extremely short charge times of just a few seconds provided by capacitors. It's no longer necessary to replace accumulators or batteries. The electric double-layer capacitor, or EDLC for short, is also referred to by many as an ultracapacitor or supercapacitor. At first glance, it is similar in design and appearance to the electrolytic capacitor, but it actually features a completely independent technology. The EDLC stores energy electrostatically through polarization of an electrolyte solution. There is no chemical reaction such as we expect from other methods of energy storage. Like all capacitors, it comprises two electrically conductive surfaces known as electrodes. What determines its capacity, or in other words, its ability to store charge, is both the distance between the electrodes and the area of the electrode surface. In order to keep the capacitor as small as possible, but with the greatest possible capacity, a layer of activated carbon powder is usually applied to the wafer-thin aluminium foil. This creates a spongy, porous activated carbon layer with an enormous internal surface area and a capacitor with a capacity of up to several thousand farads. Liquid electrolyte is the electrically conductive connection between the two electrodes. The two electrodes are kept apart by a separator. If a charge voltage is applied to the capacitor, the positive and negative charge carriers are arranged on the complementary pole of the EDLC. This produces potential. When energy is discharged from the EDLC, the reverse situation occurs. The charge carriers positioned on the electrodes are distributed freely in the electrolyte. In terms of energy and power density, this technology fills the gap between conventional capacitors and accumulators. Charge and discharge currents ranging from just a few amps to several thousand amps are typical, as well as backup times of 1 second to 60 seconds according to the application. Consequently, they can definitively be characterized as power components for short-term intermediate energy storage and are best suited to all applications where immediate power is required. For example, to start internal combustion engines, in agricultural machinery, heavy goods vehicles, or cars. Another positive characteristic of the double-layer capacitor comes into effect here. At low temperatures in particular, they're able to deliver much higher currents than conventional batteries. They can even function at -40 degrees Celsius without any problems. In many cases, they also offer significant weight advantages over a purely accumulator solution. An additional major advantage of the double-layer capacitor is its durability and reliability, which makes it ideal for applications with high maintenance costs due to the exchange of batteries or accumulators. It's possible to achieve lifespans in excess of 10 years and 1 million charge and discharge cycles according to rated voltage. And it's used in the field of renewable energies, for example the pitch control in wind turbines. The ultra-fast charge and discharge times mean that it's also an appropriate solution in many other applications. A key example of this is, you need your cordless screwdriver to put up new shelves, but the battery is flat. If your tool was powered by a capacitor, it would be ready for use again in just a few seconds. A working example has been set up with 5 cells, 350F, connected in series. The charge time is determined by the possible power of the charger. For example, a charge current of 20 amps results in a charge time of 30 to 45 seconds. In the specified example, this provides sufficient energy to screw 40 SPAC screws of 4mm by 40mm into natural wood. This solution means that you'll never have to buy expensive replacement batteries. The battery is also a defining and important factor in electric and hybrid vehicles, particularly with regard to the subject of recuperation and thus increasing efficiency with no loss of heat. Extremely positive results can be achieved with the aid of double-layer capacitors, particularly when used in combination with accumulators. When braking, the kinetic energy can be transformed into electrical energy via a generator and temporarily stored in a double-layer capacitor within a few seconds. This provides increased efficiency in comparison with the battery, thanks to its ability to be charged with several hundred amps within seconds. The energy stored in the capacitor is now available for the acceleration and startup process. This achieves noticeably higher torque values in comparison with a vehicle powered by an internal combustion engine. Fuel consumption and CO2 emissions are optimized. Double-layer capacitors facilitate a high number of charge and discharge cycles. They permit very high charge and discharge currents, and in comparison with batteries, they have a very high service life and cycle stability. They offer a wide operating temperature range and are virtually maintenance-free, are reliable in harsh environments, and can be connected both in series and in parallel to meet your precise requirements. The EDLC technology offers you new opportunities and many advantages. Be open to change and new directions. Always remember that power makes the difference.